everyone. This is the new subject that is data structures. We are going to learn, and in this video, we are going to discuss about Unit 1, that is Introduction to Data Structures, Abstract Data Types, Linear List, Singly Linked List Implementation, Insertion, Deletion, and Searching Operations on Linear List, Stacks, Operations, Array, and a linked representation of stack applications, queues, operations, array, and link representations. Okay, let's see one by one. What is data structure? The subject name itself, data structure. First, we need to understand the meaning of a data structure. Whenever we want to work with a large amount of data, whenever we are working with a large amount of data, then organizing the data is very important. Okay, when we are working with a large amount of data, organizing the data is very important. If the data is not organized effectively, if the data is not organized effectively, it is very difficult to perform any task on that data. Okay, if it is organized effectively, then any operations can be performed easily on that data. If we are organizing our data well, we can perform any task on that organized data. Whereas if we're not organizing the data well, we cannot perform any operations on that, right? Let's see what is the exact definition of data structure. Here, data structure is a way of collecting and organizing the data in such a way that we can perform operations on these data in an effective way. That means this data structure is a way of collecting and organizing the data. It can do both the works at a time, that is, it can collect and also organize the data in such a way that we can perform operations on these data in an effective way. Based on the organizing method of data structures are divided into two types. We already told that data structure is a way of collecting and organizing the data. To organize the data, we also have some methods of organizing methods. So how many types of organizing methods are there in data structure? Two types, that is linear data structures and non-linear data structures. Okay, let's see one by one. Here, linear data structures. What is linear data structures here? If a data structure organizes the data in sequential order, then that data structure is called a linear data. That means if we are arranging the data in a sequential order, that means in a particular order, in a way that, for example, roll numbers of your class students, from where we can organize that by 1, 2, 3, 4, 5. This is the sequential order of your class roll numbers, right? So we are arranging the data in a sequential order. That means order wise, 1 after 2, 2 after 3, like that. Okay, that the way, if the data structure organizes the data in a sequential order, then that data structure is called a linear data. For example, linked list, stack, and queue. These three comes under the linear data structures. Okay, we'll learn further about this linked list, stack, and queue. Okay, what is non-linear data structure here? Non-linear data structure is nothing but it organizes the data in a random order. That means it doesn't have any order like the linear data structures. Okay, hierarchical, then the data structure is called as a non-linear data. That means it is not having any structure, or it doesn't have any order, particular sequential order. Okay, it will stores the data as a random way. For example, tree, graph, dictionaries, heaps, tries, etc. These are the examples of non-linear data structures. Okay, we also see these examples of one by one in the further classes. This is called as a non-linear data structures. Okay, let's see what is a linked list here. The linked list is a linear data structure that contains a sequence of elements such that each element links to its next element in the sequence. Each element in a linked list is called a node. Okay, remember that this linked list is nothing but the name itself is saying linking. Linking means linking to the next element. Each element links to the next element in the sequence. Okay, and this each element in a linked list is called as a node. We'll call it as a node, not an element. We'll call it as a node. So each node contains how many fields here? Two fields, that is data and the next field. It is linking, the data node is linking with the next node. Okay. Data part represents data part represents the value which we want to store, and the next part represents the addresses of the next node in the list. That means this data, here this data represents which value we want to store in it, and this next represents the address of the next node. That means next part represents is the address of the next node. This is the node structure of linked list. How many types of linked list are there here? For us, there are three different types of linked list: single linked list, double linked list, and circular linked list. Okay, these are the three different types of linked list. We'll discuss these three types in the next video. Okay, thank you.